Die-cast magnesium vs. aluminum, understanding the differences and applications. This article will explore the comparison of die-cast magnesium vs. aluminum, highlighting their physical and mechanical properties. We will also delve into the specific applications of each metal, providing insights into the industries that use them. The purpose of this article is to help readers understand the differences and similarities between magnesium and aluminum in die casting, as well as their various applications. This article aims to provide readers with the comprehensive comprehension of the disparities and resemblances existing in die casting between magnesium and aluminum, along with their diverse utilizations. Upon reaching the conclusion of this piece, we will have acquired an enhanced comprehension of the metal that best aligns with particular applications, thereby facilitating informed decision making when faced with the choice between these two metals. Properties of magnesium and aluminum. Aluminum and magnesium, as metals, possess individual characteristics that grant them versatility in diverse applications. Here are some of their properties. Density. Aluminum has a density of 2.7 gcm, which is about 1/3 the density of steel. Magnesium has a density of 1.74 gcm, which is the lowest of all structural metals, and about 2/3 the density of aluminum. Melting and boiling points. The melting point of aluminum is 660 C1-20F, and its boiling point is 2519 C4566F. The melting point of magnesium is 650 C120F, and its boiling point is 1090 C1994F. Reactivity. Magnesium is a more reactive metal than aluminum, which means it readily reacts with other elements and compounds, including water, acids, and oxygen. Aluminum, on the other hand, is less reactive and resists corrosion in most environments. Strength and stiffness. Aluminum has good strength and stiffness properties, making it useful in many applications where lightweight and high-strength materials are needed. Magnesium alloys are even stronger and stiffer than aluminum alloys, making them suitable for applications where strength and stiffness are critical, such as the aerospace and automotive industries. Conductivity. Both aluminum and magnesium are good conductors of electricity and heat. Aluminum is usually employed in electrical wiring and as a heat sink. Magnesium is used in electronics and medical devices. Corrosion resistance. Aluminum is resistant to corrosion in many environments, but can be corroded by salt water. Magnesium is susceptible to corrosion and needs to be protected with coatings or alloys to improve its corrosion resistance. Ultimately, it is important to grasp the physical and mechanical traits of magnesium and aluminum to figure out which metal is the right fit for particular die casting tasks. While magnesium is lighter, has a lower melting point, and better thermal conductivity, aluminum is stronger and more ductile. When choosing a material for die casting, it is vital to take into account the particular needs of the application and carefully evaluate the advantages and disadvantages of each metal option. Contrasts between magnesium and aluminum in die casting. Magnesium and aluminum are widely employed in die casting due to their exceptional mechanical and physical attributes, making them highly favored metals in the industry. These properties vary between the two metals and can affect their suitability for different applications. A notable distinction in the physical characteristics of magnesium and aluminum lies in their density. Magnesium, being the lightest structural metal, possesses a density of 1.74 gram per centimeter. In comparison, aluminum has a density of 2.7 grams per centimeter, making it approximately 1/3 heavier than magnesium. This difference in density can affect the weight and overall cost of the finished product. Another critical physical property to consider is the melting point of each metal. Magnesium has a lower melting point of approximately 650 C, while aluminum has a higher melting point of around 660 C. The lower melting point of magnesium can be advantageous in die casting because it requires less energy to melt the metal, resulting in lower production costs. Thermal conductivity is another important physical property to consider when choosing between magnesium and aluminum. Magnesium has a higher thermal conductivity than aluminum, meaning that it can dissipate heat more efficiently. This makes magnesium ideal for applications that require thermal management, such as electronics. In terms of mechanical properties, tensile strength is one of the most critical factors to consider. Tensile strength indicates the force needed to pull a material until it breaks. In comparison, magnesium has a lower tensile strength than aluminum, implying that it may not be the best choice for applications demanding high levels of strength. However, magnesium does have excellent ductility, meaning it can be bent or shaped without breaking. This makes magnesium ideal for applications that require flexibility. Elasticity is another important mechanical property to consider when choosing between magnesium and aluminum. Elasticity refers to the ability of a material to deform and return to its original shape when a force is applied. Magnesium exhibits greater elasticity than aluminum, enabling it to endure more deformation without fracturing. This quality renders magnesium well suited for applications that demand durability. Ultimately, while magnesium is lighter, has a lower melting point, and better thermal conductivity, aluminum is stronger and more ductile. When selecting a material for die casting, it is essential to consider the specific requirements of the application and weigh the benefits and drawbacks of each metal. Applications of die-cast magnesium. Die-cast magnesium has numerous applications due to its unique properties. This makes it a popular choice for various industries. Some of its applications include: 1. Automotive industry engine blocks. Magnesium is an exceptional option for engine blocks because it combines lightness with a remarkable strength-to-weight ratio. Magnesium engine blocks can be up to 50% lighter than traditional cast iron blocks, resulting in improved fuel efficiency and reduced emissions. Transmission cases. Magnesium is also commonly used in the manufacture of transmission cases. Due to its low weight and excellent thermal conductivity, the material's ability to dissipate heat efficiently can help reduce wear and tear on transmission components. Steering wheels. Magnesium is a popular choice for steering wheels because of its high strength and excellent vibration dampening properties. These properties help to reduce driver fatigue and improve comfort while driving. 2. Electro-Ninsendry laptop frames. Magnesium is widely used in the production of laptop frames. Due to its high strength-to-weight ratio and excellent thermal conductivity, magnesium frames are thinner and lighter than traditional metal frames, resulting in lighter and more portable laptops. Mobile phone frames. Magnesium is an ideal material for mobile phone frames because of its low weight and excellent strength. The use of magnesium frames in mobile phones has become increasingly popular due to the demand for thinner and lighter smartphones. Camera bodies. Magnesium is an excellent choice for camera bodies due to its strength, lightweight, and excellent vibration dampening properties. Magnesium camera bodies can help reduce camera shake and improve image quality. Overall, die-cast magnesium is an ideal material for applications that require lightweight, high strength, and excellent thermal conductivity. It is particularly suitable for the automotive and electronics industries, where weight and thermal management are critical factors in the design and manufacture of products. With its numerous benefits, it is no surprise that die-cast magnesium is a popular choice for manufacturers across a wide range of industries. Applications of die-cast aluminum. Die-cast aluminum is widely used in various industries due to its unique properties, making it a popular choice for different applications. Some of the most common applications are: 1. Automotive industry wheels. Aluminum is a popular material for wheels due to its lightweight and excellent strength. Aluminum wheels are lighter than traditional steel wheels, resulting in improved fuel efficiency and handling. Cylinder heads. Cylinder heads are often made with aluminum due to its impressive ability to conduct heat and its lightweight nature. Aluminum cylinder heads dissipate heat efficiently, helping to reduce engine wear and tear. Intake manifolds. Aluminum is also a popular choice for intake manifolds because of its low weight and excellent machinability. Aluminum intake manifolds can improve engine performance and fuel efficiency. 2. Aerospace industry aircraft parts. Aluminum is widely used in the aerospace industry due to its excellent strength-to-weight ratio and excellent corrosion resistance. Aircraft parts made of aluminum include wings, fuselage, and other structural components. Satellite components. Aluminum is also used in the manufacture of satellite components. Due to its excellent thermal conductivity and low weight, aluminum components can help dissipate heat generated by electronic components on board, ensuring optimal performance and durability. Rocket parts. Aluminum is used in the production of rocket parts due to its high strength-to-weight ratio and excellent corrosion resistance. Aluminum rocket parts include fuel tanks, engine components, and other structural elements. Overall, die-cast aluminum is an ideal material for applications that require lightweight, high strength, and excellent thermal conductivity. It is particularly suitable for the automotive and aerospace industries, where weight and thermal management are critical factors in the design and manufacture of products. With its numerous benefits, it is no surprise that die-cast aluminum is a popular choice for manufacturers across a wide range of industries. Conclusion. In conclusion, understanding the differences in applications of die-cast magnesium and aluminum is critical for choosing the right material for specific applications. Magnesium has unique properties such as low density, high strength-to-weight ratio, and excellent machinability, making it ideal for applications in the automotive and electronic industries. On the other hand, aluminum is widely used in the automotive and aerospace industries due to its high strength-to-weight ratio, excellent thermal conductivity, and corrosion resistance. Choosing the right material for specific applications is crucial for achieving optimal performance, durability, and cost-effectiveness. At Sunrise Metal, we specialize in providing high-quality die casting services for aluminum, ensuring that our customers receive the best solution for their unique requirements. Contact us today to learn more about our services and how we can help with your next project.